Hello everyone, this is Ashagri from Etio IT YouTube channel. Today I will be doing how to compute crude odd ratio and adjusted odd ratio using SPSS, which is a repetition of a video that I did 3 weeks ago. And this time I will be doing in English because the former one was done in Amharic, and based on the request that I've been received from the comment section that some of you guys have been requesting me to do that video in English, so I will be doing this video in English, and I hope it will help you in doing your research. So without any further ado, I will just get into it. So as you all know, the objective of any research study is to get from point A to point C, or point B for that matters. So let's assume that A is our initial point, the point that we start looking. So A may represent a research problem. So we have a research problem that we want to solve, or a research question that we want to find the answer. So A represents dependent variables, or an outcome variables, a variable that we want to study and find out the a solution to it, or an answer to it. And C on the other hand represent solutions, or a way to look into A. So they are more like independent variables, variables that determines the variability or the change in variable A. So we call them independent variable or explanatory variables, or sometimes we even call them predictors, because they are the ones who will determine in the change or variability of the variable A. So once we know and find out the possible potential variables that might have a potential effect or a plausible effect on variable A, so we will determine if these two variables has any sort of association between among each other. So we use to determine that associations statistically, or statistical measurements. So in finding out the true value between, or the association between the two variables, if only we count a one-to-one relations regardless of the effect of any extraneous set variables, we call that value a crude value, because we don't take account into the set variable that may have any kind of involvement or any kind of effect in between, the association between the dependent and the independent variables, or the variable C and the variable A. But if we go further and try to understand if C may have any relation with B, let's say some hypothetical variable B, or any hypothetical variable C, and try to understand if this variable has any relation among each other, or if B has got any relation or association or effect on the variable A, the same with D as well. So when we consider the effect of these third variables in the association between the two, we are trying to roll out the chance that may that may underestimate or overestimate the association between variable C and variable A. So since we are trying to control or to rule out the chance between the variables, we are doing adjustment. So we are going to more into the adjustment analysis. We call it adjusted odd ratio, or adjusted any kind of statistical method that we are using to determine the association between the two variables. So in determining if there is any existing relation between the two variables, we might use different statistical methods. But for now, we will be using odd ratio. At some instance we might use relative risk, but the problem with relative risk is we're supposed to use incidence-based data, but for now we don't have that kind of data, so we'll be using odd ratio, because odd ratio can take prevalence data in measuring associations in a way it also helps us in measuring risk between the two variables. And for our exercise in calculating or computing adjusted odd ratio and current odd ratio, I just bring you a raw data that has been used in research study of the prevalence and associated factors affecting occupational health hazard in health facilities at Addis Ababa, Ethiopia, 2002. So after we done the analysis, the presumed result report is supposed to look like this. This is the research report result that we're supposed to produce. So as you can see on the report, we have the descriptive data. The descriptive data means it's a 2x2 table data that shows the distribution of each person's between the outcome variables and the explanatory or the independent variables. So it can give us clearly how this statistical tools or this statistical result is how likely it's true. So whenever we present our odd ratio or our statistical report, we have to always bring the descriptive data along, otherwise it won't be able to prove what we have on the associated result is true or not. So let's get to it now. So I have this raw asbestos data from the research that I showed you previously. So the first thing we do is, since this is an exercise, I will be randomly choosing a variable so that we can easily compute the association between the outcome. The outcome variable is the last variables. It says occupational related hazard within the last year. So this will be our dependent or outcome variable that we'll be considering for the analysis. The rest is independent or explanatory variable that we'll be using in determining the variability of this variables. So before running into the regression, what we should do first is the descriptive analysis, which is we'll go to analyze, click. From the descriptive statistics option, we'll go to crosstab. This crosstab helps us to understand the distribution of variable across the variables, I mean the independent variable across the dependent variable. So we have rows and column. Let's remove this variable for now. Let's start from scratch. And now for the row, we should consider the independent variable. For instance, let's take sex. And for the columns, we will consider the independent variables. So we can just simply execute the result. So it can give us a 2x2 table distributions. So when you can see this table, we can clearly see that how many number of male individuals would have been exposed to the occupational health hazard and how many were from female professions. So we can easily see the distribution. So we will do the same for the rest of the variables, so that when we make our table presentation, we will take this descriptive statistics and fill in the table later on. Let's do one more to make it more clear. So we go to analyze again, descriptive statistics, cross tab. So we will remove this sex by this arrow dragging, and let's drop profession again and run the same descriptive statistics as well to know that how the population of professions have their distribution look like across the outcome variables or the dependent variables. So bear in mind this statistics whom I use it later on. So once we done this descriptive statistics, the next step is going to be the analysis option. So in order to do the crude odd ratio, we have two options. We can use cross tabulation in running out the odd ratio. At the same time, we can use binary logistic regressions. But the problem in using cross tabulation in measuring the risk is that the two variables, means the outcome variables and the dependent variable needs to be dichotomous, or the response needs to be binary. Otherwise, it won't be able to calculate the odd ratio. For instance, let me show you how to calculate odd ratio for sex, because sex is, as we know, dichotomous. So let's put the sex, and this time what we do is we will slightly adjust the statistics, because we don't not only we want as a descriptive, but this time we want the risk value as well. So we will click the risk, and then okay, everything is the same. So we click on the confidence interval, because sorry, we don't need confidence interval, sorry, because we're calculating the crude odd ratio. So when you can see the last table, it says risk estimate. The first rows, it says odd ratio for sex, male and female, in relation to the hazard, the occupational related hazard. So as you can see, 0.322 and the confidence interval between 0.2 up to 0.5 is the odd ratio. So let's do the same with logistic regression, and if it is the same or not. So let's go to analyze, go to regression. From regression, select binary logistic. So let's remove sex again, and let's drag it back to show you what the step is supposed to take. So once we drag in the variables into the block, what we do is go to category. Let know that the variable that we input into the block is categorical, so we put in the category, and we have two options. As you know, the sex has two dichotomies, male and female. So when we record sex in the species, we said 1 for male and 2 for female. So we want to change, if we want to do comparisons between male on female or female on male, by just selecting these options. It means that when we run the regressions, it will take one of the option as a reference and compute the odd ratio for the other ones, so that when we interpret, the odd ratio for female is this amount when we compare with male. So for this time, let's just randomly select first means male, so male is going to be reference, and we're going to compute the odd ratio for female. So let's say change. When we change, it brings the first into the name of the variable. So select continue. Okay. So we will go down to the last table. It says the variables in equations. It means that the last value that we want is contained within the table at the last line. So the first thing when we see this table, what we should do, what we should see is this value, the significance value. It means the b value, or the power of the study. Since our assumption is, our decision making is entirely based on the assumption that the p-value is less than 0.05 and the confidence interval is 95%. So when you see the confidence level, it says 0.000, which means quite less than the 0.05 value of p, so which means statistically significant. So the first thing we should see the significance value. The second one is the confidence interval. If the confidence interval cross 1, it means that the variable is not statistically significant, means there is no statistical association between the outcome and the dependent variables. But when you see the value, it doesn't cross 1, means it's statistically significant, the one thing. The second one is it's less than 1. It means the risk factor is protective factor for the outcome variable. It means that since we are comparing with male with female, this is the female value. It means female has a tendency to protect themselves from any kind of occupational hazard when we compare with men. Only for this study, I'm not referring to the universal factors, but for this study, it happens that female tends to protect themselves from any kind of occupational hazard when we compare them with female profession in that particular health facility. The third thing we need to consider is comparing this value with the value that we found from the crosstab, and if you remember, the value is exactly the same with the value that we found from the cross tabulations. Look, so we can easily calculate the crude odd ratio either by using cross tabulations or binary logistic, but the problem with cross tab is our variable needs to be 2 by 2. So for this time, let's just keep using the binary logistic regression to make it simple. So let's do one more variables, and we'll go to report. Let's say profession, because profession has more option into it. So let's choose category options, select. Let's keep the rule set the same. We will choose the first one as a reference. Okay. Let's drag it down and go to the last table. So, like I said, the first focus of our attention has to be for the significance value. So almost all of the variables, maintains the rules that the p-value is less than 0.05, except for these variables. N14 professions 3 choice. The third choice is laboratory technicians. So when we go to the confidence intervals, you can see that the confidence interval, it can cross 1. It start from the lower extreme value is 0.935, and the upper extreme value is 7.6, which is over 1, which means that there is no statistically significant association between the professions of that particular profession towards the outcome variable, which is occupational hazard. So we will do the same, and we'll just easily compute the crude odd ratio either way by using crosstab and logistic regressions. And then the second choice will be running the adjusted values. So the way how to calculate the adjusted value is the same with what we use for the crude odd ratio, except for this time we are not going to calculate the odd ratio individually for each variable. Rather, we're going to drag all those independent explanatory variables into the model, so that the model is going to outweigh all the chance of overlapping association between the variables and provide us the marginal association between each independent variable on the outcome variables. So we go to analyze, go to regressions, choose binary logistic, drag out the variables, and let's put all those variables that we choose in explaining the variability of our dependent variables. So sex was one of it, professions, night shift, being aware, and then PPP, personal protective equipment. We will drag all those variables into our model, and we will let know the models that the variable that we choose is categorical variables. So we'll select again all and change it into the first for as a reference. The first category will be taken as a reference. Okay, and then finally okay. So like the same, we'll go down to the last table, and you can see that all the variable has been input into the regression model, so that it will outweigh the chance of overlap. So the first thing we do is go through the significance value, and you can see that almost all of the variable found to be statistically significant, except for the last variable, which is the use personal protective equipment, because the value is greater than 0.05. So when you go to confidence interval, like we said, it crosses 1, which means it's not statistically significant. But the rest, all the variables are found to be statistically significant, even if after we done the adjusted value or the adjustment values. So once we done all these calculations in spaces, we will copy this table into our result, and the result is going to look like this. It's going to look like this. So by we'll just copy all those crude value in one row, in one column, and the adjusted odds ratio in the other columns, and we will state the conditions of significance, which is confidence interval 95 and p-value 0.05 and less. So like I said, in our crude odds ratio, almost all the value happens to be statistically significant. But when we bring the variables into adjustment, one of the variables failed to satisfy the condition, so it found to be statistically insignificant. Not only that, when you go through in detail the strengths of the association between the variables, some of the variables they found to have a higher or a stronger associations, and some of the variables found to be less strong association. It means that the effect of one variable on the other one tends to affect in both ways, either in overestimating or underestimating the effect of the variables on the outcome variables. So once we find the adjusted odds ratio, what's next? So the main objective of any research study is in order to produce information so that we can use that information for decision making, for any policy making, for any rules making, for any kind of research and project and program development. So all those recommendations, conclusions and decision making entirely will be done based on these adjusted values, because adjusted value gives us exactly the effect of one variable on the other one without the effect of chance between the two variables. So in such a way we can easily calculate the adjusted odds ratio so that we can get the information that we need from the raw data. So I hope you find this video helpful in carrying out your research study. And before I go, I also like to remind all of you that if you have any questions or any tasks that you want me to carry out for you, just leave it in the comment options. And for those who are new to my channels, if you find it interesting, I will also have so many resources to bring you in the future videos. So don't forget to like and subscribe my YouTube channel. Thank you very much.